good afternoon, everyone, and thank you for taking the time to join us for today's Cure Cancer's Researchers Lunch and Learn with our brilliant researcher, Dr. Mara Zeissig, who's based at WEHI, which is the Walter and Elizabeth Hall Institute of Medical Research down in Melbourne. My name's Nikki Kinloch. I am the CEO of Cure Cancer, and I will be taking you through this session, which will last around 45 minutes. Please do feel free to ask questions. In fact, we encourage that. And you'll be able to see a chat box there on the right-hand side. So just type those in as and when you think of them, and I will weave those into the conversation with Mara. We also have a QR code at the bottom right-hand of the screen, and should you wish to make a donation whilst we talk, please do so by clicking on that QR code, and it will take you to our donation page. So back to today. It's the middle of Lung Cancer Awareness Month, and we are interviewing one of our brightest emerging cancer researchers to tell you about her work on lung cancer. Dr. Mara Zeissig is a Lung Cancer Foundation Australia Low Survival Cancer Philanthropic Early Career Research Fellow at WEHI. That's a lot. Originally from Argentina, Dr. Mara moved to Australia when she was 8 years old, and she's always been fascinated by medicine, veterinary medicine, and medical research. Dr. Mara's research aims to identify tailored and more effective treatments for lung cancer, which is responsible for the highest number of cancer-related deaths in Australia, sadly. Her research also aims to determine whether combined treatments with immunotherapy, which uses the immune system to fight cancer, can successfully kill tumours. So that's a lot of words, so let's start to unpack that. Welcome, Mara.
Thanks, Nikki.
Lovely to have you here today. So we heard originally that you moved here from Argentina. Do you want to just explain to the audience a bit about your background and what got you interested in cancer research?
Yeah, sure. So when I was 8 years old, my dad got a job in Australia, and so we moved on a skilled migrant visa back in 2003. My dad is actually a farming consultant, and so he essentially helps mainly dairy farms manage their farms more efficiently. So in terms of how many cows to have per hectare and things like that. And so given that was his job, we moved to Mount Gambier, which is a regional town in South Australia. And so I did my schooling there and lived on a farm. And so we did things like raise baby lambs that were abandoned by their mums. And so it was a very wholesome childhood. And I really, really loved it. And so then for uni, being in a regional town, I had to move to a capital city. And so when I was 18, I moved to Adelaide and lived in one of the colleges there, which is like student accommodation, which was fantastic because I met all my best friends, everyone at this residential college, and did a Bachelor of Science at the University of Adelaide. And once I finished my science degree, during that process, it was really clear to me that cancer was what I was really quite interested in, mainly because it's this concept of your own body kind of betraying you and your cells going haywire, and why that happens and how to actually fight that is, I feel, a lot more complicated than if, for example, if you have an infectious disease where it's an external pathogen that's coming into your body. So the idea of having to try and fight your own body is quite, in a research perspective, is quite interesting. So when I was listening to some lectures and stuff at the university, I decided to join the South Australian Health and Medical Research Institute. It's called SAMRI, which you might also know it as the cheese grater, in Adelaide. And I did my PhD there in blood cancer in multiple myeloma. With actually my supervisor was Dr. Kate Van Dyke, who is another Cure Cancer alumni, coincidentally, which is fantastic. So I did my PhD with Kate, but at the end of the PhD, I really, really realized that my interest was in immunotherapy. So trying to use the immune system to fight cancer. Back to that concept of when you have an external pathogen like a virus, your body's immune system is what fights it off. So how can we do that, but with cancer. I find that quite fascinating, and it really feels like that's one of the big avenues for potential cure, because just like our body most of the time can clear a virus, maybe we could also clear the cancer. So it's yeah, quite a fascinating research area. And so to be able to do that, I had to move to Melbourne. So at the beginning of 2020, literally right when the pandemic hit, I got a job in Melbourne. So I moved there all very optimistic, thinking that the pandemic wasn't going to last that long. And then I was locked down for like 2 years. So not the best time to move to a new city. But, you know, made the most of it. I worked with at Monash University with Professor Tony Tiganis, who is really interested in triple negative breast cancer and liver cancers, and really trying to get an immune response in these cancers. And so that really set me up with this concept of trying to use immunotherapy, trying to use targeted treatments, all very specific to each type of cancer. So then I took all of that and moved to the Walter and Eliza Hall Institute, still in Melbourne, to work with Kate Sutherland on lung cancer. And again, looking at these very hard to treat lung cancers that don't respond to any immune therapies at the moment, and are just beginning to have these really tailored drugs that could work. So it's a really exciting research area. So that's why I moved over there.
Yeah, look, definitely a journey, and I don't think anyone would oh, you poor thing, turning up to Melbourne in the middle just before lockdown. So probably not the best way, as you say, to start, but well done for getting through it like the rest of Victorians. Now, before we talk about your lung cancer research, you talk about immunotherapy, and there might be some people on this call that don't quite understand what that is, because it is quite a new concept. So do you mind just talking a bit more about immunotherapy and why it's, well, one, revolutionary, and two, so important nowadays?
Yeah, so I guess to understand immunotherapy, you kind of have to step back and think about what happens when your body is infected with a virus or a bacteria or any other external damage. So what happens there is your immune system, well, there's different, we're not going to go into too much detail, but essentially your immune system recognizes something as foreign and releases toxins to destroy it. So when your immune cells see a virus, they'll destroy it. So that's kind of the concept there. But the clever thing about cancer is that because it's your own cells that have gone awry, your immune system doesn't recognize it as foreign. And so you don't get attack on the cancer. And so the problem there is that that's called immune evasion. So the cancer is able to evade the immune system. So it's quite clever in that sense. So what immunotherapy does is it takes that concept of, okay, when do your immune cells recognize things as foreign, and how do they do that? And then trying to apply that to specifically to your cancer cells, while at the same time avoiding normal cells, because if you just initiate an immune reaction, you're going to get autoimmune diseases, which is also not something that we want. So you don't want to cure someone's cancer and then give them a debilitating autoimmune disease. So there's a very fine balance there. So the way immunotherapy works is a person is administered with an agent, which is normally, well, probably the one that people have mostly heard of is called anti-PD-1. And the idea there is that it blocks inhibitory signals on the immune cells. So normally, if your immune cell sees something that it doesn't recognize as foreign, it deregulates its activity, and it doesn't kill anything. So when you come in with a drug that removes those inhibitory signals, the immune cell is suddenly awake and will attack. So that's essentially what people get given when they talk about immunotherapy, is they just reactivate the immune cells. So that's the most basic immunotherapy that can be delivered to any cancer, I suppose. It's kind of universal. But you can also start to get more tailored specific immunotherapies. So again, people might have heard of infusion with CAR T cells. And this is where your immune cells are actually taken from your blood, grown in the lab, engineered to specifically target your cancer and then infused back in. So they work really well for blood cancers because your blood cancer is kind of everywhere and it's within your blood, so it's fluid. So the immune cells are able to detect a cancer cell and attack quite easily. But when you're talking about a tumor mass, the immune cells have struggled to get in there, and so you don't get as good a response. So that's the current struggle with immunotherapy, is how do we get the immune cells in there when it's a tumor mass? So that's where the work is at the moment.
Yeah, so no, we've heard, thank you for explaining that. We've heard about how cancer cells are very smart, you know, and they talk to each other, and they also talk to your good cells as well. So the invention of, or development of, immunotherapy has been very critical in helping break that down. And I know some of the researchers have also said to us in the past that this also impacts the patient being able to have less toxic treatments as well in some cases, because the immunotherapy is doing that work instead of other types of treatment too.
Yeah, and so one of the questions I'm looking at the moment is there's these new drugs for lung cancer, and so first of all, they do directly kill the cancer cells, but one of the other things that they do is actually improve the area around the cancer to allow the immune cells in. So they almost remodel the environment the cancer's in. So that was one of the questions that I'm also looking to address with this project, is if we give both this cancer drug first, remodel the environment, and then come in with immunotherapy, whether you get a better response to treatment like that. So that's also a big research avenue at the moment, is how do we create an environment that is conducive to immune cells getting in there and actually like recognizing and killing the cancer. So we've learned, I think, that unless it's blood cancer or maybe some very rare melanomas, or sorry, not rare melanomas, melanoma as a rare example of a solid tumor, most of the time we can't just deliver one immune cell activating immunotherapy. We need to do a combination of lots of different things at the same time. But that then adds side effects to patients, and so that we need to work quite closely with oncologists and figure out, if I give this patient, can I give this patient 2 drugs at the same time, or are the side effects going to be too much? So there is that to think about too.
Yeah, no, absolutely. And thank you for explaining that. So obviously you talked about you starting your research life in Adelaide and then moving over to Melbourne to focus on lung cancer. Why lung cancer in particular?
Yeah, so I think lung cancer for a long time has been quite associated with the stigma of smoking. And so historically, there's actually not been a lot of money for research. And so then not a lot of research has actually been done. So in contrast to, for example, something like breast cancer or prostate cancer, which have quite a lot of research funding, and there's been a lot of work in those cancers. And so as as more of a biology and, more fascinating research kind of angle, lung cancer to me was quite interesting because it's still really in quite an early phase of research where we really still don't actually understand the biology of all the different types of lung cancers. So there's a lot of work to be done from the grassroots level in that sort of sense as well, more basic research before we can think about new therapies. So that was kind of why I chose lung cancer. Yeah, it's just a bit more interesting to research at the moment, I suppose. Yeah.
I mean, it might come to a surprise to most of us to hear that lung cancer research is not as popular or underfunded, given that it is sadly one of the biggest killers in the world as well. We've spoken to other researchers who have talked about the incidence and rise of non-smoking lung cancer due to our factors, like diet, pollution, etc. So this is obviously becoming a significant problem as well. So what's your research in particular? So you identified lung cancer needs more research, more funding. And then once you started looking at that, where did you start to target from a lung cancer perspective?
Yeah, so there are, I think all kind of with all cancers, we're starting to move towards this concept of lung cancer is not one disease, just like breast cancer is also not one disease. So there are multiple different types of lung cancers. And the one we're particularly focused on is driven by a gene called KRAS. And KRAS normally in our cells functions as a on-off switch for cell growth. So you can kind of already see how a cancer would very much like to hijack that system. So instead of there being a natural on-off system so that our cells only divide and grow when we need them to, in a cancer state, for these lung cancers, that gene is always on, and so you get constant growth of these tumor cells. So it's a very hard to treat disease, and the issue there is that there wasn't really a lot of options in terms of therapies for that cancer. So just your normal chemotherapy and radiation, which could be quite toxic to the patient, and now recently immunotherapy, but we're not really seeing responses like we would want. So a couple of months increased survival isn't really something that's, I mean, it's important, it's very important, and so we are making slow progress, but you really want a bit more longer term survival for these patients and better quality of life. Yeah. So KRAS, one of the reasons I got interested in it is that in the last 2 years, there've been the development of drugs that can actually bind this gene and turn it off again. So this was absolutely massive for this field. I think it took about 30 years to get to this point where they could actually create a drug for this gene. It was termed undruggable for about 30 years. So when it came through, and it's also very specific to the cancer version of this gene, not the normal one. So your normal cells are completely spared. So you also don't see a lot of toxicity, which is fantastic. So these drugs, they're very new, and so they're not quite as potent or as effective as we would want them to be. They're very first generation drugs. But it sort of speaks to how hard to treat these cancers are, is that they're already being used. They've already been FDA approved, and TGA approved, and so they're already being used to treat patients, both in the US and overseas, as well as here in Australia. So that's where there's a lot of research going on now, and including what I'm looking at is how can we make these KRAS drugs better? So not necessarily from a altering the drug perspective, I'll leave that to the sort of chemists, but more about what other drugs that we currently use can we use in combination? Does that make it better? Can we replace some drugs with it instead and to make it less toxic? So there was actually some of the recent results coming through that having just a KRAS inhibitor alone was just as effective as chemo. And you can already see that just from a quality of life perspective, that it's better to have a drug that has no side effects versus chemo. So we're not extending survival or anything like that, but what we're doing is at least providing a drug now that has got less side effects so that the person can enjoy their life better. So that's definitely a work in progress with these drugs, but they're showing really, really promising outcomes already. So what I'm looking at is, again, when we think of lung cancer and KRAS mutations in lung cancer, so that's one type of lung cancer, but really within, when you have a KRAS mutation or an alteration, there is other genes that can also be affected. And so you almost have to also look at different types of KRAS lung cancer. So it gets very complicated. But that's something that actually our lab is very, very interested in. So looking at the different types of KRAS lung cancer. And we're already seeing early results that depending on what type you have, you respond better or worse to the KRAS drugs, which again speaks to that concept of, okay, right now they're being used instead of chemo, but potentially, even though they have less side effects, that patient you're giving it to might not actually respond as well as they would have to chemo because they have a different subtype of the KRAS lung cancer. And so it is really important to delve that a little bit deeper and look at what type of KRAS lung cancer they have. So that's, another thing that we're looking at the moment.
Yeah. Lovely. Well, thank you. I'm just going to pause there and welcome, seeing we've had a few new people. Thank you for joining us today. I'm talking to Dr. Mara Zeissig, who is cure cancer, early career cancer researcher at WeHi in Melbourne, and we're talking about her work on lung cancer. So a couple of questions that have come in, and to the audience, if you do have any more, please type them in the box on the right-hand side there, and I will roll them into the conversation. A couple of questions for you, Mara, about that. So obviously lots of different types of lung cancer, different mutations of this KRAS gene. How do you identify that someone has this mutation and needs to have it treated?
Yeah, no, that's a very good question. So, and that is also something that is being lobbied quite heavily by consumer groups and clinical groups, is the fact that to be able to identify KRAS or any other genetic alterations in the lung cancer, to be able to then categorize it into the different type and be able to tailor the treatment for the patient, involves sequencing of someone's tumor. And that sounds, so depending on what center someone goes to, it depends on how accessible sequencing actually is. So it's becoming really, really good at the moment. So most people have access to sequencing. And so that allows you to identify the different subtype of lung cancer. And there are essentially everyone gets given access to a small sequencing panel that will just be looking at some of the key drivers of lung cancer, just to be able to sort of bucket people initially into the different type, but to then go delve a bit deeper, which is what I was saying in our research, is to, yes, you have KRAS, but what more? That involves more sophisticated sequencing, and so not everybody has access to that at the moment, but that is something that is oncologists and the medical community is very, very aware of, and it's slowly being rolled out and becoming, just like any sort of technology, the longer we use it, the cheaper it gets, and so the more and more accessible it becomes. But in general, we would know if a patient has a KRAS mutation in all circumstances. So yeah.
And then on a question on that mutation, is that obviously a genetic mutation, but is that something people are born with, or is that something that occurs through life?
Yes, that's a good question. It's weird because we use the word genetic alteration in research, but to the general public, that kind of implies that you're born with it. But really, no, that's not the case. So when you talk about a genetic mutation in cancer, it's really one single cell in your body has an issue when your machinery in your cell reads your DNA to be able to then split your cells into two, and etc., which happens all the time. So our entire body gets regenerated every, I think it's 7 years. This is a fun fact. So that's constantly happening, and your cells have really good checkpoints and monitoring to make sure that your DNA is perfect from one cell to the next, like daughter cell. But unfortunately, there are problems that happen along the way. And so it is literally as simple as luck in that sense, is that there's an issue with the copying of your DNA into the daughter cell. And as soon as you get one issue, it's likely that there's a bit of a snowball effect and you get more and more issues. So when we talk about genetic alteration, we literally mean in that sort of cell dividing phase, which happens in our bodies. So the older we are, the more likely that a mistake happens, which is why you see a lot of cancer relatively a lot more cancer in people that are older than young people, just because of probability really of something going slightly wrong.
Yeah. Lovely. Thank you for explaining that. And then another question for you about the percentage. So this type of mutation, or the larger KRAS bucket, if you like, what percentage, if you have a number on this, do the people that have lung cancer have this KRAS mutation or some form of that mutation?
Yeah, it's actually relatively common. So lung cancer very broadly is two types, so either small cell or non-small cell, and non-small cell accounts for 80% of cases, so the majority of them. And then within non-small cell, a third of those have a KRAS mutation. So it really is a very key driver of the most common lung cancer that we see. So it is actually a very, very high percentage of patients that have lung cancer that have this mutation. And we're actually seeing a lot more of that coming up in, like you were saying before, in actually non-smokers. So it's quite common in non-smokers to have this KRAS mutation as well.
And can that mutation happen in other cancers as well, or is this specific just to lung cancers?
Yeah, no, it definitely can. So I think it goes back to that sort of fundamental concept that KRAS is an on-off switch for cell growth. And so depending on a sort of where in your body that mistake happens and your KRAS gene gets left on rather than being able to be switched, that would lead to a type of cancer. So we see quite a lot of KRAS mutations in pancreatic cancers as well as colorectal cancers. In pancreatic cancer, it actually drives about 90% of all cases of pancreatic cancer. So it's a very, so it happens in quite a lot of different cancers, which means that actually these new drugs that target KRAS are not only going to be helpful for those lung cancer patients, but they're being used for other cancers as well at the same time. So anything that we find in our research with lung cancer may also be applicable to these other cancer types as well. So, yeah.
And that's great. I mean, we hear that all the time, and that's what we often talk to our supporters about, that although researchers generally focus on one type of cancer, that those learnings go across other types as well, which is very exciting. So back to your specific mode of research. So we have these buckets, one of them being the KRAS mutation, and within that there's many different alterations, and you're very much looking at the treatment of that. So what stage are you at in your research? Are you still doing the identifying, or have you got to a point where you can identify and then look at some form of treatment with the combination drugs that you were talking about before?
Yeah, so we made quite considerable progress this year on this. So we, in the lab, because we're quite interested in the different types of KRAS lung cancer, we have quite a lot of models that we can use to look at the most common types. So there's about, altogether, there's quite a lot. There's probably 10 or more types, but really there are 3 that are the most common that we see, and most patients have those other alterations. And so I've been using a lot of the models that we have in the lab to not only mainly focus on those top 3 because they're the most common, but also look at all of them. And what I've found so far is that one of the most common ones, which is, so it happens in about 20% of these patients, that subtype is actually resistant to the KRAS inhibitor, which is really important to know, because especially because that subtype is also responds quite poorly to other therapies that we're currently using. So that was something that, so found that out about maybe 6 months ago. And so now most of my focus at the moment is looking at why that subtype is more resistant to the KRAS drugs, and what we can use in combination with the KRAS drug to resensitize this particular subtype to treatment. And the other important thing about identifying these things is that, again, when a clinician or a doctor goes to decide what sort of treatment a patient is going to get, if even though the KRAS drugs have less side effects, if we know that that patient has this other alteration that is resistant, then there's no point in subjecting that patient to that treatment, and they're probably better off having something more standard like chemo, even if it is more side effects, but at least you get a therapeutic response. So yeah, we've definitely started to go a bit deeper now. So we've identified 1 or 2 that are resistant. I've also identified some that are really sensitive, and so those patients would just be able to be treated with just the KRAS drug and get nice response and no side effects, which is fantastic. So given that these drugs went to the clinic so quickly because there's such few options for these patients, we're almost now having to just take 1 step back and figure out, okay, well, which one of these patients are actually going to respond the best, rather than just treating everyone because it was the best situation at the time. Yeah, so there's a lot, I'm doing a lot more sort of resistance mechanism work at the moment. So why are these cells more resistant, working out what the pathways are that they're upregulating to evade sort of killing with the drug, and what we can do to sort of shut that down. So that's currently working on.
So for those people that have been identified as having some form of positive reaction to this drug and turning this switch off, what does that mean? And I appreciate you're not a clinician, but what does that mean to the patient? Does that mean that their lung cancer stops growing? Does it mean it shrinks? Does it mean it goes away? What have you seen so far?
Yeah, so I guess probably something to compare it to would be there's other lung cancers that are driven by another gene called EGFR. So there's, don't need to worry about what that means, but essentially it's another type of lung cancer, but they have drugs that block EGFR. And at the moment, if you're a patient and you have that mutation, there are people that are living 10 years with their lung cancer. It's a drug that has very little side effects, that has really good quality of life. So, which is absolutely fantastic. So in contrast to that, the KRAS drugs at the moment, we're talking months that they kind of, and we're not seeing necessarily shrinkage of tumours, we're just seeing sort of stabilization of disease. So extended, survival, which is not where we want to be, I suppose. We want to be at the 10 years kind of concept. So there's a lot of, but at the same time, there is so much work in this now that we have even anything to work with. So after 30 years of nothing, it's been 2 years of, okay, now we have a baseline drug that we can now improve. So it's definitely, and the other thing is, so KRAS works quite differently to something like EGFR because it's a toggle on-off switch. It's harder to target. So I guess we weren't necessarily surprised by the fact that it wouldn't work amazingly like the other subtypes, but it's definitely a very good starting point. And so now we have the ability to have second generation drugs, third generation drugs that are more potent. So you have to deliver less drugs, so less side effects, and people can take them for longer. So it's definitely a really exciting area, and it's getting better and better. And again, not only for lung cancer, but it would help pancreatic cancer patients, colorectal cancer patients. So it's definitely a massive area of research at the moment.
Well, look, first of all, congratulations to you and your team for getting this far. You know, as you said, it's been 30 years, and look at the progress that's happened very quickly. So well done on that. And obviously, this is not just going to impact people locally, but globally as well, which is very exciting. On that, do you do any international collaborations at the moment, or is that something that you are looking at if you're not currently?
Not directly at the moment. Most of our collaborations are actually within Australia, but it is definitely something we're looking at. We have collaborators in Japan who have access to more patients. So, in Melbourne, I mean, we have the Peter MacCallum Cancer Centre right next door. So we do work quite closely with the doctors there. But to be able to look at lung cancer and then KRAS and then specific KRAS, you're really getting down to people in the less than 1,000 kind of people that will be presenting to something like the Peter Mac. So it's not that many patients that we can work with or have access to samples. So it is important to go international in that sense, to be able to really have access to bigger groups of patients, see how important our or how many patients our research findings would be applicable to, and things like that. So at the moment it's quite relatively local, but it's definitely on the cards to try and get access to more patient samples from overseas.
Yeah, look, I understand, and I mean, you've made so much progress already, which is wonderful. There's a question here that I was going to ask about the importance of you receiving this funding, I think it's very obvious. I mean, the progress that you and your team have made on something that hasn't had much progress at all in 30 years is phenomenal. So well done on that. But in your own words, you know, how important is it for early career cancer researchers to be funded?
Yeah, it's vital, really. So if you're looking at a sort of a career, a research career, you really do need seed funding to be able to demonstrate that you're able to, just like any sort of job, like meet project milestones, you know, actually do what you said you were going to do and stick within budget and all those kinds of things. Because if you look at wanting to run your own lab, you'd be giving essentially no one's going to give you $1 million to do research if you've never handled any money or shown that you're capable of sticking to budget before. So it's a very clear sort of crux for early career researchers that if we can't demonstrate that we're able to acquire any form of funding, then you're very unlikely to be trusted with lots of money. So and that kind of is the end goal, is to be able to have your own lab and be self-sufficient and run multiple research projects at the same time. So so it's very, very important in that sense. It's also very important just for sort of charitable organizations like Cure Cancer, where it really is quite humbling to think that it's that these are just everyday Australians that are donating their own money for us to be able to do this work. So that, and alongside our consumer representatives, which are people who have lived experience with cancer, who are also part of our research projects, and we provide them with updates. So between charitable organizations and then these consumers that have experience with cancer, it really grounds you as to what you're really doing, rather than getting caught up in just running experiments and not really thinking about the bigger picture. So it's all really important.
Yeah, absolutely. Thank you for explaining that. And one question here about collaboration. So we often see it, you know, once you have a bit of funding from our generous donors here at Cure Cancer, we like to consider our researchers and our alumni as part of a family. And we know, and we have many of our researchers collaborating currently. You obviously talked about how you worked with one of our alumni in South Australia, but are you working with any others at the moment, or is that on the list for you to do?
Yeah, it's definitely on the list. I think like when we do Cure Cancer dinners and things like that, we really can get to know everyone a lot better. So there are a couple of other lung cancer researchers also funded through Cure Cancer, such as Dr Mara Zeissig, for example, who's up in Queensland. And so meeting people at these Cure Cancer sessions has actually allowed me to, we're now in sort of email contact and establishing a bit of a collaboration, because we have sort of similar but complementary interests in lung cancer. So he does a lot more patient analysis, whereas we do a lot more lab work. So it really complements each other. And my PhD supervisor, Kate Van Dyke, she her actually original Cure Cancer research funding that she got was part of my PhD project. So I sort of benefited from Cure Cancer funding without even really realizing, because at that point I was just a student and I wasn't thinking about how to fund research, I suppose. So, and we're obviously still in contact, and she actually reviewed my Cure Cancer application. So it's like a very good example to have a look at hers, and then to help me write mine. So yeah, so it's really fantastic. And the events that we get to do mean that we get to all meet and talk to each other. So it's a really great community.
Yeah, look, thank you. And before I wrap up here, because we're almost out of time, you know, what are your hopes for the future with the work that you are doing? Where do you want to end up?
Yeah, that's a very good question. I suppose my hope is that we can kind of keep thinking of cancer as a very sort of personalized medicine approach. So really tailoring each person's treatment to their cancer, because we've known for a long time that every person's cancer is unique, but I think we've now gotten to the point where we have the technology and the ability to actually act on it. So it's a very exciting time. And, you know, cancer is a very scary thing. So being able to be in a small part of that sort of revolution and getting to that point is really exciting. So I'm not planning on leaving cancer research anytime soon. I think it's a really, really rewarding job. And, you know, we can always do better. So I know there's a lot of conspiracy theories about we already know how to cure it and we, you know, just not using it. And that's completely false. It's a very complicated disease. So, and yeah, so it's always, yeah, I think the future holds a lot of sort of more tailored, making cancer something that's not a death sentence, and something that we can treat just like we treat other diseases is the goal. Yeah.
Well, thank you very much for your time. Lovely to talk to you about your work, and, you know, closing on that, to make cancer something that's not a death sentence. I don't think anyone could have said it better than that. Thank you to our audience and our guests. I hope you enjoyed this session. Mara is doing groundbreaking work here, and as she has said, this has been long overdue for more than 30 years for something that sadly is one of our biggest killers in the cancer sector. So thank you from all of us for your hard work and your team, and please do pass that on to your team. Mara, it's been a pleasure to chat to you this afternoon. And for those that have joined us, thank you. I hope you enjoyed that talk. If you do have any other questions, please write to us at info@curecancer.com.au. And then coming back and join us same time on Thursday, the 7th of December, for our Lunch and Learn with Dr. Eric Kusnadi from the University of Melbourne, where we'll be talking about his work on prostate cancer. But until that, stay safe and thank you. Have a good afternoon. Goodbye.